Conditional probability and properties. Consider an experiment of rolling a die. Let us define event A as getting an odd number and event B as getting a number less than 4. Suppose we want to find the probability of getting an odd number less than 4. This means that we have to find the probability of getting a number less than 4 when we know that the number is an odd number. And this is only possible when an event A has already happened and we are finding the probability of event B. Also, events A and B are dependent events because clearly occurrence of one affects the occurrence of the other event. In such a situation, we find the probability of getting an odd number less than 4 using conditional probability. Conditional probability states that if A and B are dependent events, then the probability of B when A has happened is called conditional probability of B with respect to A. And this is denoted by this. And given as probability A intersection B upon probability A provided probability of A not equal to 0. Here A is the event that has already occurred. B is the event that may or may not occur. This line indicates given or provided. So the conditional probability of B is nothing but the probability of B given that event A has already occurred. So the probability of getting an odd number less than 4 will be the probability of getting a number which is both odd and less than 4 divided by the probability of getting an odd number. Therefore, the probability of getting an odd number less than 4 is 2 upon 3. So this is known as conditional probability. Let us now discuss some properties of conditional probability. According to the first property, if A is an event of a sample space S of an experiment, then probability of S given that A has occurred is equal to the probability of A given that A has occurred, which is equal to 1. According to the second property, if A and B are any two events of the sample space S and E is an event of S such that the probability of E is not equal to 0, then probability of A union B given that event E has occurred is equal to the probability of A given that event E has occurred plus the probability of B given that event E has occurred minus the probability of A intersection B given that event E has occurred. In particular, if A and B are disjoint events, then probability of A union B given that event E has occurred is equal to the probability of A given that event E has occurred plus the probability of B given that event E has occurred. According to the third property, if A and B are two events of a sample space S of an experiment, then probability of A not occurring given that event B has occurred is equal to 1 minus probability of A given that event B has occurred. These are some very important properties of conditional probability which are very useful in solving problems related to conditional probability.